you're flying and you are flying west. So it says your cruising speed is 210 miles per hour. So like that's kind of what the speedometer tells you, like that the plane is trying to go 210 miles per hour, but wind is going to affect your cruising speed. So you are flying due west. So you do need to know north, south, east, west. Um, West is where we live on the West Coast. So our vector will look like this. The plane's vector is heading west at 210 miles per hour. And then the wind, it says, and the cruising altitude, it doesn't matter. That's actually like extraneous information. But the wind blows southeast, so that's this direction, at 64 miles per hour. And due southeast means like exactly southeast. So we're going to be like 45 degrees here, 45 degrees here. So it's negative 45 degrees, okay, would be due southeast. So this is your plane's vector. This is your wind vector. And the resultant gives you like what is direction and speed is the plane actually traveling in. Like you're trying to head west, but the wind is going to affect that. So your plane's vector is going to be, and this one should be easy, you're going backwards 210, up 0. And then the wind vector is, and like I said, it's going to be like negative 45 degrees, or you can call that 315 degrees. It doesn't matter. Negative 45 degrees and 315 degrees are the same. But the wind is going to be, magnitude is 64 cosine of negative 45 degrees, comma, magnitude sine of negative 45 degrees. So I'm not going to go over why that is. We've talked about this before in the example problem I did in your notes. And then the resultant, so you need to plug this into a calculator, is going to give you like how, it's going to give you the component form of like the actual plane, like what is actually happening. So what I would do is I would add my x components, and my y component is just going to be this because it's plus 0. But you're going to add your x and your y components. I will just tell you that when you add them up, you get, and you should do that part on your own so that you know how to do it. It's going to be this. So this is actually where the plane is traveling. So if you think about it, like you're trying to actually go west, but the wind is kind of pushing you downward. So that's why this answer is negative, because if the wind is heading southeast and you're trying to head west, well, that's going to kind of push your the plane's direction more west, southwest. Okay. And then to find the resultant speed, find the magnitude of, so this is P plus W, right? So find the magnitude, which just uses Pythagorean theorem. That gives you like the resultant speed. And you can do that in your calculator. And then the direction would be tan inverse, right? Theta is equal to tangent inverse of your y over x. So it'd be negative 45.255. And like you should use more decimal places, divided by negative 164.745, ... Like store those in your calculator, right? Store that as A, store this as B, and then do tangent inverse of A over B. And that will give you your theta. Now, I want to remind you that tangent inverse will only give you answers in the first and fourth quadrant. This is clearly in the third quadrant, right? Because it's a negative. So when you plug this into your calculator, you're going to notice it gives you an angle in the first quadrant. It's going to give you like this. But you already know you're supposed to be down here in the third quadrant. So you need to add 180 degrees. So I'll tell you that's going to be part of it. That's why I always want you to think about your component form versus the answers you get. Is it reasonable if I have a negative x and a negative y for my answer to be in the first quadrant? No. So you need to add 180 to your resulting theta. Okay. All right. And then part B says the plane flies for 1.5 hours. Where will the plane be relative to Houston? So remember that Houston is due west at, so I'm looking for the information. From New Orleans, you're heading due west, which is 315 miles away. So Houston is here. It's 315 miles away from New Orleans. Okay. But remember, shortly after takeoff, that's when like the wind started blowing, and then you ended up with like this resultant vector, right? So the resultant vector was this. So you want to figure out, okay, how far am I from Houston? So what you want to do is once you find the resultant speed, okay, so your resultant speed is like 170 point something. What you're going to do is multiply your resultant speed, multiply that times, multiply that by 1.5, because your resultant speed is miles per hour, right? Multiply that by 1.5 hours, and you get number of miles. And that's how many miles that you've actually traveled after 1.5 hours. So take your resultant speed that you got from part A, multiply it by 1.5, okay? And then that's going to be this side of your triangle. And then you're not even going to use vectors anymore. You're basically just going to use law of cosines to find this side here to figure out like how far away from Houston you are. So figure out how far away from New Orleans you are using resultant speed times 1.5, and then use law of cosines to find that third side. Okay, so remember that you'll know what this angle is because you will have found the resultant angle theta here. So if you think about like this is your x-axis. So if you go all the way around, that gives you your theta here. So what you're going to do to find this little angle in your triangle is subtract 180 from your answer for theta in the previous part to find this angle. So again, to find this side of your triangle, it's resultant speed times 1.5. To find this angle, use your previous theta and subtract 180 to find that little angle. Because remember, Houston is west, okay? New Orleans was east. So this theta here is in the third quadrant, but usually in triangles, we don't, actually always in triangles, we shouldn't have something greater than 180, right? So we have to subtract 180 to get this angle here. And then you can use law of cosines to solve for this side length, okay? And you should get, I'll tell you, something around 96. Okay. And then lastly, part C, suppose the pilot's aware of the weather conditions. What direction should the pilot fly the plane in order to have a true course towards Houston? So in other words, we don't know what angle it is. So we would have something like this. Okay. So for this part of the problem, sorry, I was interrupted, so I'm restarting this video. Okay, what direction? Okay, so in this case, we are now trying to fly directly west, but we know that there is wind heading southeast. So this is what we want, but we know we still have the wind, and we need to figure out what is the plane's direction, okay? So I want you to think about this logically. If I'm heading west, but I know that there is a wind that's heading southeast, what direction is the plane going to have to head in so that if the wind affects it, it's still heading west? So you know your plane, if you think about it logically, is going to have to be like this. It's going to have to be heading northwest so that the wind, when the wind affects it, the resultant, actually, sorry, that's a bad picture. So like if my plane is like this and then the wind is like this, the resultant, remember, your resultant looks like this. So we want the resultant to be heading directly west. But what we need to figure out is like, what is the plane, the plane's direction and speed so that it heads directly west. So considering the wind. So what we're going to do is I'm going to set it up again as like, okay, so the wind, the thing we know is 64. Was it 64? 60, yeah, 64 cosine of negative 45 degrees, comma, 64 sine of negative 45 degrees. So that's my wind vector. So that hasn't changed. And then we need to add that to the planes vector. And the planes vector, I don't know. So the planes vector, I don't know what the magnitude is. Oh, wait, yes, I do. Is it changing speed? Went directions to the pilot order. Using this course, how long? Okay, so we're not changing speed. We're just changing direction. So it is still 210. But we don't know what theta should be. And then 210 sine theta, same theta. And then let's think about what we want. We want the plane to be heading directly west. Now, I don't know what the resultant speed is going to be, so I'm going to call that, I don't know, x. But if I'm heading directly west, I do know that so I don't know like what the magnitude of this vector is, but I do know that the vertical component is going to be 0. Because if I'm heading west, then I am not heading neither north nor south. So I want my resultant to have a vertical component of 0. So that's what really helps me solve this problem, because then I know my y components add up to be 0. So the y component of my wind vector plus the y component of my plane's bearing vector basically has to equal 0. And then you can solve this equation. And you should end up with a theta that is in the second quadrant. Now, I say that knowing that I'm not going to get that. Now, okay, what do I mean? I'm supposed to get something in the second quadrant, but I know I won't get something in the second quadrant. So when you're going to solve this equation, so you're going to subtract this from both sides. You're going to divide by 210, right? And you're going to get theta equals sine inverse of blah, 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 which you can figure that out yourself using basic algebra. Now, sine inverse, as you recall, of course, from chapter 2, is going to have the same problem that I had with tangent inverse on this problem. So remember on this problem, I did tan inverse and I got a theta in the first quadrant, but I actually needed it to be in the third quadrant. The same thing's going to happen here. Sine inverse only exists in quadrants 1 and 4, but I know from my picture right here, remember, it makes more sense for my plane to actually be in quadrant 2. So I happen to know that my answer is going to be down here when I solve for theta, and I'm going to have to add 180 to get a theta that actually makes sense. So I just want to point that out. Sorry, that's my cat, Jack. Please go away. And so just remember that sine inverse and tangent inverse only exists in quadrants 1 and 4 for the outputs. And you're going to have to add or subtract 180 in order to get answers if they're supposed to be in quadrants 2 and 3. Which again, that's what happens here. Is we have an answer that should be in quadrant 2. So solve that yourself. You can do that in your calculators, and you're going to end up with your theta. And then the final part of this is how long will it take to reach the destination? So how long will it take to reach an 315? So what I would do is I would find the magnitude. Once I find what theta is, then I can solve for x. So what I would do at this part for the second part of part C. So again, I'm not going to do this for you, so just make sure you're paying attention. Pause the video if you need to. Solve for theta. And then what I would do is plug theta back in, find the magnitude, which is going to be, in this case, it's actually pretty simple. Since the y component is 0, you just have to find what the x component is of the resultant, right? And then what you can do is it would be x times time is equal to 315. So then it will be time divided by the x component of your resultant vector, because the x component by itself will be the magnitude. So let's say you're traveling at, once you find theta, and then you add your x components to find the resultant vector. Let's say the resultant magnitude is like 200. So then what I would do is I would do 315 divided by 200, and that will give me the amount of time it will take to get to 315 miles. Because remember, the magnitude of your resultant vector is the resultant speed. Okay, so in this case, because the y component is 0, the resultant speed will just be x. Normally, what you would have to do is do the square, to find the magnitude, right? To find the magnitude, I would have to do the square root of x squared plus your y squared. But since the y is just 0 in this case, it's the square root of x squared, which is just x. So in this case, the magnitude is just x. And then that's your resultant speed. And then 315 divided by your resultant speed. Because remember, rate times time is equal to distance. Distance equals rate times time. Or rate equals distance over time, if you want to think about it that way. Rate equals distance over time. Your rate is the speed. That's your resultant speed. Okay. Okay, so that is kind of an overview of that part. And again, I'm not solving this whole problem for you, so this should give you enough to try to solve it yourself. And then, again, if you didn't understand it, just do it slowly. Pause the video as you do the problem, and then finish it yourself. Okay, and then lastly, unfortunately, the pilot in the previous problem does not realize his error until you are due south of Houston. What course should he fly in order to head straight for Houston? How long did the entire trip take? Okay, so sorry, I'm trying to figure out, is this the plane flies for 1.5 hours. You do not realize the error until you are due south of Houston. Okay, so I'm just checking. Okay, so we're ignoring the 1.5 hours part. So we don't, we're saying that, okay, Houston, so for part C, Houston is here. We are here. Okay, so we are already here, which I'm going to have to figure out how long it took me to get there. But now I have to figure out, how do I get up to Houston? So what I want is I want the plane plus the wind to equal not going anywhere in the x direction, but going up in the y direction. Oh, this is not part C. I'm sorry, this is 99. And this is actually very similar to part C on the previous problem, in that I have to figure out, like, okay, I know what the wind is. The wind is 64 cosine negative 45, 64 sine of negative 45. So I know that's the wind vector. The plane's vector is my unknown. So I don't know what my plane's vector should be. It's going to be 210, because that's a speed, cosine of theta, and then 210 sine theta. And I want the resultant to be, in order to go straight up, that's going to have to equal 0, comma, some y coordinate. Okay? And that's going to have to be my resultant. So that's going to be W plus P. So similarly, I have a 0 component, which means the easiest thing for me to do would be to set this up as 64 cosine of negative 45 plus 210 cosine theta is equal to 0. And then you're going to solve this very similarly to 98C to solve for theta. Then you need to figure out, let's see, we need to figure out how long that will take. So let's see what information I have. Houston, New Orleans to Houston is 315. So Okay, so again, you can solve this for theta. Let's see, will you need to add or subtract 180? So the wind is this way. So the plane will need to be heading in the second quadrant. So yeah, when you solve for theta, oh wait, cosine exists. Sorry. When you solve for theta, you're going to end up with cosine inverse of something. I'm going to let you solve that part for yourself. You will get the actual theta. It should be somewhere in the second quadrant. And that's because cosine inverse, unlike sine and tangent inverse, actually does exist in quadrants 1 and 2. So your answer for theta should be somewhere in quadrant 2, so that your plane is heading in quadrant 2, your wind is heading to quadrant 4. The resultant of that will head directly north. Okay, so anyway, back to this final part, which is like, how long does this whole thing take you? So we have 315 is the distance from New Orleans to Houston. And then this is going to be some side length, I don't know. I think we can just use theta from part 1, because it says you do not realize your error until you reach south of Houston. Okay, so this theta here is going to be the same theta, and it is a right triangle. Your theta is going to be the same as your theta from part A, same as number 98, part A, is going to be your theta. And then I think you should just be able to use SOHCAHTOA, right? Tangent of whatever that theta is equal to, we'll call this y, although this is a different y than this one, so let's not call it y, let's call it like a. Sure. So this side length a here, so tangent theta is equal to a over 315, and so then you get a is equal to 315 tangent theta, and that gives you the distance that you are from Houston at this point. And then to figure out the time that it takes you, we can do the same thing to find this side length. We'll call this side length b. So that would be cosine theta is equal to adjacent over hypotenuse. So we'll end up with b is equal to 315 over cosine theta. Again, this is the same theta as number 98a. So you can find both of these in your calculator to solve for a and b. Actually, you could have also just used Pythagorean theorem once you solve for a. It doesn't matter. Pythagorean theorem, SOHCAHTOA, use some basic trig to find side lengths a and b. And then just divide that by your resultant speed in order to solve for because these are just distances, to figure out how long it's going to take you, okay? So b is the distance. A and b is like distances, right? A is the, actually I'm going to say b and a are distances. So to solve for it, because it says solve for the amount of time, yeah, how long does it take? So remember, distance is equal to rate times time. So once you solve for your distances, you can divide them by the rate to solve for time. Now the rate for B, we already solved for in part A. We solve for the resultant speed here in part A. So look for your resultant speed from part A and divide that from B. Okay, so B here, take that B, divide it by the resultant speed from 98A in order to find the amount of time. That's the time for the first part of the journey. And then you're basically going to do the same thing here. Okay, you need to find the resultant speed from this. So that's going to be your y value. So you're going to do A, so side length A, so A is the distance, divided by y, and that was from here. because that's the resultant speed. So remember, A is a distance, Y is the speed. When you divide that, you get the time for the this part of your journey. Okay, so I know I just threw a lot at you. If you need to, stop, rewind, rewatch. So to find the time that it takes for this part of your journey, you're going to find the distance and divide it by the resultant speed, which you already did in 98A. To find the time for this part of your journey, you're going to find this distance and then divide it by your resultant speed from 99. And then add those two times up in order to find the total time. Okay, so I got you started on a lot of this. I do want you to try to finish it. If you come to me asking for help this week, that's fine. But I want to see that you at least, I'm going to ask you to like take this out and show me that you attempted to finish each of these problems that I've already started for you. So don't come in and like ask me to explain this from scratch unless you truly, truly need me to. But otherwise, I'm pretty much just like, there's only so many ways I can explain this. I'm really just going to direct you back to watch this. Slow it down if you need to, stop it, rewind it, make sure you understand each step as you do it. Because I know this is like probably the hardest problem that I've asked you to do thus far. But I mean, it's not a bad problem. It's still a good problem. It contains a lot of separate parts that I do expect from you from a test. Like, I do want you to be able to figure out the resultant speed. I do want you to be able to find a direction. I do want you to figure out like what's a total distance if you know a rate and a time, and to be able to finish a triangle using law of sines or law of cosines. So it's, this is a lot in one problem. If I'm being honest, I probably wouldn't give you this problem on a test, but I would give you like parts of this problem. Like I might give you like just this part where I say like, okay, what is the direction that you need to head in order to go directly north given this wind vector and this magnitude, and then you'd have to figure out like, okay, what's the missing piece here? And that's the theta. And then figure out like, okay, part of this is 0. So then these two have to add up to be y. And these two have to add up to be 0. So this is the one that's most useful to me because they add up to be 0. Things like that. So a lot of good pieces in these two problems. So still make sure you can do all of the pieces in these problems.